Okay, let's look at another example. It's a very simple example, but an extremely important one because it involves one of the most important tendons in the human body, which is the Achilles tendon. Okay? And so we just want to find out, what is the torque that this Achilles tendon, if attached to the heel, can apply about the ankle joint. Okay? And so much of our motion, so much of what makes us active, moving human beings happens simply because of this one torque. And anyone who's ever had damage to their Achilles heel knows exactly how limiting and devastating it could be if it's tore or does not work properly. Okay? So, once again, torque is just equal to RF sine of theta, right? And so we want the torque of the Achilles tendon about the ankle joint. The ankle joint's there. That's going to be our axis of rotation. And we will just go ahead and say, well, we know that the force that the Achilles heel is putting on the ankle joint, according to this problem, right? The one on the slide that says the Achilles tendon. This force is just 720, right? Okay? And it says that it's the ankle joint, this distance right here, is located about 3.6 times 10 to the minus 2 meters from where the force is applied. So this distance right here is 3.6 times 10 to the minus 2 meters. Awesome. Okay, so torque is going to be 3.6 times 10 to the minus 2 meters times 720, which is the force, times sine of the angle, right? But remember, it's the angle between this line and this force. They give us something different. They give us this 55 degrees, which is this angle here. In order to actually find the angle between the force and this line of action, okay, we need to take 90 minus 55 to get that, which I believe is 35. I hope so. Otherwise, I'm going crazy. Okay. So the torque that the Achilles heel that is applying about this axis of rotation is going to be, according to my calculations, negative 14 Newton meters. When you put this all in your calculator and calculate. Why negative? 3, 2, 1. Because this force here wants to make the foot rotate, right, around in a clockwise manner, all right? And any forces that make an object want to move clockwise or rotate clockwise is a negative torque. Whereas, if we had another force here, which technically we do, which is the normal force acting on the foot, this would provide a positive torque because it would make if you push a force up here, it would make this, and I pin this area right here, it would make the foot want to rotate counterclockwise. Okay? I hope you guys can see that distinction. All right. That is the torque of the Achilles tendon.